Let's talk about one of the hardest ones, trickiest ones was probably 28. So let's look at that one. Because it says division in the middle. Okay. Shh. So, what did we do last year when we were dividing fractions? You guys remember? Okay, yeah. When you divide fractions, what do? Shh, girls.
You flip it to
You flip the second one, and then it becomes multiplied.
Oh, I missed that one.
You flip the second one. This is the only problem that looks like this. Okay. When you multiply two fractions together, the tops get multiplied together, and then the bottoms get multiplied together. And really, it's just like one giant fraction. But we still need to simplify it. So I'm going to do this in alphabetical order. Let's start with A's. I see one A and no other A's. So guess what I'm going to do with the A?
A.
Just A. Okay. Then let's go on to the B's. I see a B divided by B squared. You guys remember how we did this on Friday? What do we do with the exponent?
3
I
minus.
know the answer to this.
So it should.
1 minus 2.
Oh, I meant 1.
Which is
Negative
-1, which means
Negative.
no.
It's just negative. It's
Second.
No.
Due to the first
Okay.
one
B to the -1
would be on the bottom, so B just B over B1.
is 1 over B. It does not affect, so it's going to be a B on the bottom. It does not affect the negative or positive value of the term. It just moves things up and down.
I can know the answer.
Okay, and then I see one C on the bottom, and that's the only one I see. Okay. And then how many X's are we going to
I
have?
see what you did there.
Shh.
0.
Right, they're going to cancel out. 2 minus 2 is 0. X to 0 is 1. 1 times whatever is whatever. So the X's just cancel out. How about the Y's?
There's going to be 2 Y's.
3 minus 1 is 2. It's not negative, so it's still going to be on the top. Y is the second. Okay, that was 28. You guys have any requests on 1 through 30 besides 28?
24, 26, and 30.
I'll do one of them, so why don't you choose?
Can you finish? You should do 12. Wait, hold on, that's it?
Yeah.
That's the answer.
Number 12.
That's what I got.
Oh, that one.
Okay, 12 is tricky with the negatives because how many negatives does number 12, like normal negatives, not exponent negatives?
2.
No.
Not 2.
Okay, there's 1. And there's 2 more. So 1, 2, 3. There's 3 negatives. You guys see what I'm saying?
Yeah.
Negative k squared is negative k times negative k. So really this represents 3 negatives. 1, 2, 3. I'm not talking about negative exponents, I'm talking about this. So 3 negatives multiplied together makes a negative. So what you do is you just put a negative out in front and then forget about the negatives after that.
Let's do it.
Okay, and then as far as the letters go, see a J squared and a K. So what do I have with the J's? 1 minus 2. Negative 1. So, or J on the bottom. So what's happening is this J is canceling out with one of those J's, and that leaves a J on the bottom. Okay, so how many K's do I have? Negative 2 minus 1. Negative 2 minus 1. Negative 3. So k to the negative 3 or k to the third in the denominator. So nothing's left on top, so 1 on top. So, let's see. Willow, you want me to do 24?
Yeah.
You said 24, 26, and 30.
Yeah.
30 is probably the easiest because you just multiply the -3 on the parentheses and then you add the x's together. Do you guys remember that you're not supposed to leave a negative exponent answer unless you're doing 17 through 22? On that part, you're just leaving a negative exponent. 24 says, well, 30, 26 might be true. Let's do 101. Over 2x negative 2. Not a lot to do on this one. You guys know what 38 divided by 2 is? 24.
24.
19. Okay, x2 divided by x negative 2.
No,
-4.
0.
2 minus negative 2.
Oh, that's negative.
2 minus
It's
negative 2
4. Oh, plus
is
4,
4.
Hey, I said that like.
Okay, and then the y's, we got 3 minus negative 2.
5.
3 minus negative 2.
5.
Okay, and then on the z's, what do I got on the z's? Just a z to the -1, right? That's the only one. So what am I going to do with the z to -1? Put it on the bottom as a z.
Yeah.
Okay, I'm not going to do 26, but let's talk about the 6 and the 2. So 6 to the -1 is like what? Right, it's like a 6 on the bottom. And 2 to the -2 on the bottom is like what?
4.
2 to the -2 on the bottom is like what?
2 squared.
2 squared on top.
Yeah.
And what's 2 squared?
4.
4. So if we simplify those numbers, it's 4 over 6. And what does 4 over 6 reduce to?
3 times.
2/3.
2/3.
Oh, that.
So you can start that problem with the 2 and 3. Remember how I said just extend that division bar, the fraction bar, and then just put your letters out here. How about this? Let's today's assignment probably won't take as long, so let's do today's, and then we'll grade at the end of class, which is like, we'll grade in like 35, 36, 37 minutes, something like that. Okay, so starting on today's. That way if you have any questions or you want me to look at something, I can do that. Scientific notation. You actually did this, well, I wasn't there, but probably you did this in 7th grade a little bit. Well, I'm going to teach it from scratch, so even if you forgot, you can remember. But does anybody have a vague recollection of what scientific notation is?
A squared plus B.
No, that's
the long thing.
that's Pythagorean theorem. I think there might be a lesson on that in this book. I can't remember, to be honest.
Oh, I hate my
Okay, in science, sometimes you have really big numbers, like how far is it from here to the next galaxy, or how many cells are in the body. Sometimes the numbers are so big that it's really a big pain to write them, like because they would fill the wall or something. So they figured out an easier way to write giant numbers called scientific notation. But also, this is new, like you didn't do this in 7th grade. Sometimes really tiny numbers, like what's the width of a cell or something, those are also really kind of a pain to write because they're really small numbers, take up a lot of space too. like 0.00001 centimeters or something.
Wow.
So you can also use scientific notation to make this a shorter thing. Okay, here's how it works. Let's start with this is not a giant number, but it's just for practice. 2,300,000.
23.
Nope. Oh, let me explain it. So you just always put the decimal, we're going to rewrite this number, we're going to put the decimal after the first digit. So we're going to write it as 2.3. Now, why did I not put all those zeros?
Because you don't need to do put for the 15.
Zeros at the end of a decimal do not change its value. 3/10 has the same value as 300,000 millions. Like if I added zeros on there, it's the same value. So anyways, that was confusing. Adding zeros at the end of a decimal doesn't change the value. But 2,300,000 isn't the same as 2.3. So how do I make them equal? You always do times 10, and then you just count how many places, where's the decimal on this number right here?
Off the back.
Right, it's right there. And where did we move it?
To the front.
Right here. You count how many places we moved the decimal. 1, 2, 3, 4, 5, 6. And you make that the exponent. You count how many places we moved the decimal. The decimal was right here to start with, after the 2 million. If you have a whole number, I'm sure you probably did. If you have a whole number, the decimal is normally at the end. We moved it to be right after the 2. So we moved the decimal 6 places. So you put times 10 to the 6th. Why does this work? Why are these two equal?
Because
Basically, this means we're 2.3 times 10 to the 6 means we're multiplying this number times 10 6 times. It's like times 10 times 10. What happens every time you multiply by 10?
you move the decimal.
The decimal moves one spot. So that's why these two are the same. Times 10 times 10 times 10 times 10 times 10 times 10 turns it back into 2 million. So these two values are the same. This is just a shorter way of writing it. It's called scientific notation. Does that kind of ring a bell from last year?
No.
Okay.
Yeah.
Good to know you were paying attention last year.
I was like
remember this
reading. Dude, you like reading class.
What, like a 56?
Okay. Let's try another one. This is 436 million. How did I start the last problem?
You put the decimal
The
before all the
Large
zeros.
number.
Decimal after the first digit. 4.36. And then what do I do?
Times 10.
Times 10.
And then you count how many places.
How many places did the decimal move to get right there?
80.
Yeah. Can you guys count by threes?
Yes.
3,
6,
6, 7, 8. It goes 3, 6, 9, right? 3, 6, 9, 12. That's counting by threes.
15.
Okay, that's only the beginning of the lesson. That's like number 1 through 4. Okay, but also remember I said you could use it to write tiny numbers like this. I don't know if I want to write them that tiny. Here, let me change it a little bit. Okay, if you're writing a tiny number, you're going to put the decimal right after the first non-zero digit. So I'm going to move the decimal basically right there. Okay, so it's going to start out as 1.25
Divided by.
times 10.
Or.
Okay, I'll explain. You're kind of on the right track, but I'll explain why in a second. Okay, this time we move the decimal backwards how many places? 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. Okay, but instead of putting times 10 to the 12, negative 12. Do you guys remember what 10 to the negative 1 meant? We kind of just talked about it, but 1 over 10. And if you multiply by 1/10, that's like dividing by 10. So really this is like multiplying by 10 to the negative 12th is like dividing by 10 12 times. 1.25 is a lot bigger than 0.0000125, all those zeros. So to make them equal, you have to put the 10 to the negative 12. Basically, if you have a tiny number to start with, you're just going to get a negative exponent every time. If it's a big number, like the ones we did at the beginning, it's just going to be a positive exponent. But tiny numbers, 0.0, whatever, get a negative exponent. The decimal moves the opposite direction. Okay, that's not it, but
It was like in my soul.
that's enough to get us started. Okay, number 1. You guys already write the assignment down?
In my book.
Yeah.
Yeah.
Wait, I was 22.
Can you
I'm on the
imagine?
wrong page.
I was 22.
Okay, number 1 says 390 million.
3.9.
So we're supposed to write this in scientific notation. So it's 3.9 times 10.
To the start.
Yeah, 3, 6, 7, 8. You guys get that? 3, 6, 7. I did 100 millions place a bit ago, and it was to the 8th power. That was like my second example. Anyway, that basically means 390 million. Okay, number 3. Okay, this one's a tiny decimal, 0.000, 4 zeros, 5 and 2. So what's that going to be? 5.2 times 10 to the 1, 2, 3, 4, 5. Not quite 5. Negative 5. Grant already done?
That's great. It's great for you. Speed.
Where did he go?
Took a test. We done? Okay. We just started the lesson. We've been talking about it, but
You okay?
we also talked about Friday's assignment.
The weird one that I wasn't here for.
Yeah. Wait, what were you doing on Friday?
Pep rally.
Oh, you were here for most of it. Well, you just left like 2 minutes before we did.
Oh.
But yeah, we talked about some of the evens. Okay, number 5. 5 is weird, isn't it? 13.6. Is that in scientific notation already?
Yes.
Not quite. What's wrong?
Oh, just didn't move it.
Okay, the decimal is a little bit off. So here's how it works. This is kind of a new trick. We need to move the decimal right there, right? So it's 1.36. Okay. Now we changed this from 13.6 to 1.36. Did I make that number small? Does that make the number smaller or bigger? Smaller. So to make up for it, I need to make my exponent bigger. Yes. Since I moved the decimal 1 place and it got smaller, I need to make it balanced, I need to make my exponent 1 bigger. So my normal number got smaller, and therefore my exponent got bigger to keep it equal. Does that make sense? That's kind of an important concept. Okay, nobody's complaining, so let's keep going. Number 7. 7 kind of the same thing? Yeah, it's kind of pretty similar. 235.6. Oops. Damn. This erase thing doesn't work that great. Times 10 to the negative 4. Okay, kind of the same problem. It's not really in scientific notation, even though it looks kind of like it. So I need to move the decimal right there. So it's 2.356. Okay. I moved the decimal 2 places to the left. Did I make the number smaller or bigger? It was 235.
Smaller.
It became 2.35. So I made the number smaller by 2. So what do I need to do to the exponent? Make it bigger by 2. So what's negative 4 plus 2?
-2.
-2. Okay. There. I want the evens. Number 9, express each number in standard notation. What do you think standard notation means?
Like,
Write it as the actual number.
As a normal number.
Normal.
Write it normally. So how do I change scientific back into a normal number? Okay, this literally means times 10 8 times. What happens when we multiply by a 10?
You put
Move
that
the
zero.
decimal.
Not add 0 necessarily, move the decimal.
Right. To the right.
So the first 2 moves the decimal to the right. What's my third move going to do?
Add a 0.
Add a 0. My first 2 moves don't add zeros, they just move the decimal twice. But after that, it's going to start adding zeros. How many zeros are going to get added on? 6. Because 2 moves gets me past the 4, but that leaves me 6 more moves, so that means I'm going to have 6 zeros at the end of that. So it's 2, 5, 4, and then 1, 2, 3, 4, 5, 6 zeros. If I go back and put the commas in, I can see it's 254 million. So I just moved the decimal 8 places to the right. Guess what I would have done if it was a -8?
Go left.
Go left. It would be a tiny number answer, which we're about to do one of those. Number 11. 1.53 times 10 to the -4. So guess what I'm going to do about that? By the way, it would probably take longer, but do you think you could plug this in the calculator?
Yeah.
Yeah.
Awesome.
Yeah, I'm going to move 4 to the left on this one. So my first move gets me past the 1, and then that leaves me 3 more moves. Guess what happens with the last 3 moves? Zeros. So it's 0.000153. So I just moved 4 spaces to the left. Okay, 13. On 13, we are multiplying 2 scientific notation numbers together. 2 times 10 squared. 3 times 10 fifth. So what's happening between these two parentheses? Multiplying. So we have 2 times 10 to the second times 3 times 10 to the fifth. When you're multiplying a bunch of stuff together, does order of multiplication matter?
No.
No, like 3 times 4 times 5, 5 times 4 times 3, it's all the same. So we can multiply whatever we want to together, basically. And I want to keep it in scientific notation. So what is 2 times 3? And then this is from Thursday. Do you guys remember this? What's 10 to the second times 10 to the fifth?
10 to the 7th.
10 to the 7th. So they just added the 2 exponents together. You guys remember that from Thursday? Okay, if you do it that way, see how it's still in scientific notation?
6 times 10.
Now, if you plug this in your calculator, it will give you, let's see, 6 followed by 7 zeros. 2, 3, 4, 5, 6, 7. Whoops. Darn it. Missed my spot. Anyway, it's 60 million. But you can't put 60 million for the answer because it says scientific notation. Grant, do you remember this from last year's scientific notation? If you did, you might be the only one, because others don't seem to remember very well.
I'm not
It was just one assignment in the other book, so he did
Oh, I
it
did
against
like 5 days on it, because that's.
it feels familiar.
vaguely familiar. Okay,
Your juice. I mean, your
well,
watermelon.
number 13, you probably did not do that last year. That's more of an Algebra 1 question than it is a 7th grade question. Number 15. So anyway, my point was you can kind of cheat and plug it in the calculator. Calculator gives you a normal number, and then you can turn it into scientific notation yourself.
So you really have to like show your work and stuff?
Well, I haven't really been doing, there's nothing you don't need to, when it's like 2 times 3, you don't really need to show anything for that. Or, no, this is not really a show your work thing.
Yay.
If it's easy to do it in your head, then you don't have to show your work. Now, number 21 will not be easy to do in your head, so we're going to show some work on that one. Anyway, what do you guys think I should do on this one?
Distribute the exponent.
It's like distribution. So how would I do that?
9 times 3, 27 times 3.
Right. So basically it's 3 to the 4th. 3 times 3 times 3
You
times
could
3.
have said that.
3 times 3 is 9. Times 3 is 27. 27 times 3 is
7,
8. Okay. You could use your calculator for that. It's fine. And then this goes back to Thursdays also. What's 10 to the 5th to the 4th? 10 to the 20th. Okay. I see a problem though.
It's a big number.
Well, it doesn't matter if that's a big number, but do you guys see what the problem is?
Can we do 20 to the decimal?
It's 9 scientific notation because the decimal's not right there. So we're going to have to change this a little bit.
What about 14?
Okay. I turned 81 into 8.1. So did I make that number smaller or bigger? So if I make this smaller by 1 move, I need to make this one bigger by 1 move to keep it balanced. So 10 to the 23rd, yeah. That number is really, really big. If you, well, it would just be 8, 1 followed by 20 zeros. And it wouldn't, so it wouldn't fit on your calculator, so your calculator would actually automatically put it in scientific notation because it's too big for the calculator. Anyways, number 17. Division problem. 4 times 10 to the 11th divided by 8 times 10 to the 4th. Okay, so this is kind of like number 13, except for we are dividing. So we can divide the parts. What's 4 divided by 8? It's kind of a trick question.
It's not 2.
No.
Okay,
One.
it's 1/2, but
I said that.
we're writing scientific notation. We don't want a fraction.
Just 0.5.
So it's 0.5.
Oh.
And then what's 10? This is Fridays. What's 10 to the 11th divided by 10 to the 4th? 10 to the 7th. So you just subtract the exponents there. Is that in scientific notation?
No.
No. Where should the decimal be?
Yeah.
Okay. The other side. So I turned 0.5 into 5. Now, if it's just 5, you don't really need a decimal, right? You could say it's 5.0, but really you don't need to. It's just. Okay, so did I make the number smaller or bigger? Bigger. 0.5 into 5. So if I made this bigger, I need to make this smaller. followed by 6 zeros. Does anybody know what that number would be? 5 followed 5 million.
Wow.
Okay, number 19. Almost done. Adding. Okay, try to finish this term, this phrase for me. You can only add and subtract what?
Numbers.
Non-exponents.
Like terms. I've said it so many times I thought you might be able to finish that sentence. You can only add and subtract like terms. In this case, like terms would be where both of the numbers are like 10 to the 5th or 10 to the 4th or whatever. So that's how this is going to go. 19, both of the numbers are 10 to the 3rd. So they are basically like terms, so you can add them together. Okay. Let's say you were totally not getting this. How could we figure it out? Like if you're not understanding.
Do we all?
Okay. I said this earlier. What can we do?
Combine.
No.
Add like terms.
Okay. You could plug that in your calculator. Your calculator would give you a big number, and then what do?
You make it.
You turn it in scientific notation yourself. Actually, probably all your calculators have a scientific notation button somewhere on them, but they're all in different places. And if you're gonna do it, you're gonna have to find it yourself, though, because I'm not gonna come around it. But basically, because these are both 10 to the 3rds, we have 4.3 of them plus 5.2 of them, and we can add those together. 4.3 plus 5.2 is 9.5 of those. When you add and subtract like terms, you do not change the exponents. For example, 3x squared plus 2x squared is 5x squared. 5 of those things. But do you guys know what 3x squared times 2x squared is?
Oops. Why would you do that?
6x to the 4th. Because it's 2 plus 2, basically. So anyway, when you're adding and subtracting, that's different rules. Just stays 10 to the 3rd. Okay, 21's the tricky one.
Please, no.
Again, you can still use that trick that I said. You just plug it in the calculator and change it yourself. But that's not how they wanted you to do it. And I'll explain how they wanted you to do it. The problem on 21 is that they are not like terms. Okay, the easiest way to make them like terms is by turning this into 10 to the 9th so that they're the same. Now, if I made this number 2 steps bigger,
Smaller.
2 steps smaller.
Oh yeah.
So 3 becomes 0.03. Now they're like terms. And now we can subtract. Let's see if you remember 7th grade subtracting decimals. How do we do 2.8 minus 0.03?
Something.
2.7.
Yeah, you're on the right track. Yeah, you have to line up the decimals, remember that? So, yeah. 2.77.
Bro, you
Did you
just
just
have.
stupid?
Whoops, I put 7, I should put 9. These are both 10 to the 9ths. I replaced this with this.
You call me stupid and you didn't.
Mr. Jordan, how did you do the thing where you changed it to the 9?
Well, these were different, so if that confused you, just put it in your calculator and then fix it.
We have.
We're done. Some of them are both hard. It's 22.
Yeah, 21 and 22 are the hard ones because they're not the same. They're not like terms to start with. Okay, if you have questions on Fridays, let's do that now because I want to grade it in like 12 minutes. Fridays, not today's.